Hello everyone. Okay, today let us solve some problems on flow of fluids. Write down one problem is there. Water is flowing through a pipe whose diameter changes gradually from 15 centimeter at the first end to 30 centimeter at the other end. Just a minute. Okay. Water is flowing through a pipe whose diameter changes gradually from 15 centimeter at the first end to the 30 centimeter at the other end. If the mean velocity, just a minute, just 1 minute, write down the problem. Water is flowing through a pipe whose diameter changes gradually from 15 centimeter at the first end to 30 centimeter at the other end. The mean velocity at the first end is 20 meters per second. Find rate of flow through a pipe. Second one is average velocity at the other end of the pipe. So for this, what we have to do, let us take a pipe that is diameter changes gradually from 15 centimeter at first end to 30 centimeter at other end. Okay, so here I am drawing one pipe is gradually changing the diameter. Okay, so here the velocity is v1, that is equal to velocity how much, 20 meters per second, 20 meters per second. Okay, at end 2, v2 how much, we have to find out. It didn't give in the problem, we have to find out. Here the diameter is how much, d1 equal to 15 centimeters. At exit, diameter of the pipe is 30 centimeters. 30 centimeters. So for this pipe, you have to find out first one, the discharge Q. How much is there? Next to, you have to find out the velocity at the exit. First, let us take first end. At the first end, diameter of the pipe, 0.15 meters in meters. D1 is equal to 0.15 meters. Clear? D1 equal to. Then you have to find out the area of cross section. Area of cross section at 1, that is A1, is equal to how much? Pi D1 square by 4 pi, just pi into D1 square by 4 is equal to pi into D1 how much? 0.15 meters. 0.15 square divided by 4. How much? Pi d1 square by 4 is equal to, just to solve it, 0.018 0.018 square meters. Then you take it as a velocity at point 1 is equal to 20 meters per second. 20 meters per second. Let us take at point 2. At point 2. Okay. This is at point 1. Here point 2. At point 2, dia of the pipe D2. D2 is equal to 0.3 meters. Clear? Next, A2. Area of cross section at point 2, that is A2. A2 is equal to pi D2 square by 4. Pi D2 square by 4. Then how much area we will get? Pi into 0.3 square by 4. What is the area at point 2? Just solve it. 0.071 meter square. 0.071 meter square. Clear? Now you know the area at point 1, area at point 2. Velocity at point 1, velocity at point 2, you don't know. For this, what you have to do, you can find out first one, discharge. How do you find the discharge? Q equal to area into velocity. Is it clear? That is at area 1 into velocity at 1. Then you will get 0.018 into V1 20, then you will get 0.018 into 20 is equal to 0.36 meter cube per second. 0.36 meter cube per second. Meter cube per second. Then you will find out the velocity at point 2. You know the discharge. You know area 1 into velocity 1. Okay. That is A1 V1. That is equal to A2 V2. Clear? A1 V1 equal to A2 V2. This is as per continuous equation, the discharge. Here, with the help of a discharge at 1, you can find out the velocity at point 2. You know area at point 2. V2 equal to A1 V1 is nothing but 0.36 divided by this area 2. How much area 2? 0. This is the area 2. 0.071. Finally, you will get V2. How much V2? 5.07 meters per second. Clear? Okay, you got a velocity at point 2, that is 5.07 meters per second. Now you find discharge is 0.36 meter cube per second. Meter cube per second. Clear? Understood? Right. Next problem. Write down this problem. A 30 centimeter dia pipe conveying water branches in two pipes of diameter 20 and 15 centimeters respectively. If the average velocity in 30 centimeter dia pipe is 2 meters per second, find the discharge in this pipe. Also determine velocity in 15 centimeter dia pipe if the average velocity in 20 centimeter dia pipe is 1.5 meters per second. Okay, here the diameter of the pipe is 30 centimeter. It is conveying water branches in two pipes. Here we have two pipes. You should keep it in your mind. One is 20 centimeter diameter, next one is 15 centimeter diameter. 15 centimeter and 20 centimeter, two pipes respectively. If the average velocity in 30 centimeter dia pipe is 2 meters per second, find the discharge in the pipe. Also determine the velocity in 15 centimeter dia pipe. If the average velocity in 20 centimeter dia pipe is 1.5 meters per second. Okay, so ఈ 20 centimeter diameter pipe లో velocity 1.5 meters per second. 30 centimeter diameter pipe లో velocity 2 meters per second. Then find out the discharge. Find out the discharge. First of all, for this you have to draw the pipeline like this. We have two pipes. It is connected to the main pipe. This is the other branch pipe. These are the branch pipes. We have two pipes. Okay, this pipe diameter is d1 is equal to 30 centimeters. 30 centimeters. Next one is velocity v1 equal to 2 meters per second. 2 meters per second. Here discharge we don't know. Q1 we don't know. How much? We don't know. Then this is the point pipe 1. Let us take pipe 2. In the second pipe, discharge is Q2. We don't know. Velocity at 2 is equal to 1.5 meters per second. 1.5 meters per second. Then d2 is equal to 20 centimeter dia. 20 centimeter dia. Clear? Here this is the pipe 3. For this velocity we don't know. V3. How much we don't know. Diameter we know. Diameter of the pipe D3 is equal to 15 centimeters. Discharge we don't know. Okay. So let us find diameter at point 1. Diameter at point 1 we know 30 centimeters. Then cross sectional area at point 1. Cross sectional area at 1. A1 అనుకోండి. A1 equal to pi d square by 4. Pi d square by 4 చేస్తే ఎంత వస్తుంది? Pi into d1 square by 4. ఎంత వస్తుంది? Pi అంటే 3.14, d1 అంటే 30 సెంటీమీటర్స్ అంటే 0.3 మీటర్స్. 0.3 తీసుకోవాలి, ఇది మీటర్స్లో తీసుకోవాలి. 0.3 అన్ని మీటర్స్లో తీసుకోవాలి. సెంటీమీటర్స్లో ఉంది కదా, అన్ని మీటర్స్లో తీసుకోవాలి. ఆల్ ద ఫ్యాక్టర్స్, ఆల్ ద డిజిట్స్ uh, all units are in meters. This is 0.3 meter. Then you will get how much area? Just do it. 0.071, I think, right? 0.071 meter square. Clear? Next, if you take at area 2 or velocity, you know, that is 2 meters per second. Discharge, how much discharge? Q1 is equal to A1 V1 A1 V1, that is equal to 0.071 into velocity 2 meters per second. Then you will get discharge at 1 is equal to 0.142. 0.142 meter cube per second. Meter cube per second. Then in the second pipe, find out the area. Second pipe A2. A2 is how much? 20 centimeter dia with 20 centimeter dia means 0.2 meters pi into d2 square. D2 square divided by 4. You will get 0.03 meter cube, sorry, meter square. 0.03 meter cube. Okay, 0.03 meter cube. Then find out the discharge. You know very well about the velocity v2. Okay, then discharge at point 2 q2 is equal to how much? A2 into v2. A2 into v2, A2 into v2 అనుకోండి. Small rasa. Okay, A2 how much? 0.03. This is the A2 multiplied with velocity. Velocity how much? 0. Sorry. Velocity how much? 1.5 meters per second. 1.5 meters per second. You will get 0.03 into 1.5. 0.045. 0.05 meter cube per second. Meter cube per second. Then in the third pipe, you should find out the area A3. You should find out the area A3 is equal to pi d3 square by 4. Then you will get pi into 0.15 d3 how much? 0.15 15 square divided by 4, you will get A3 equal to how much? 0.018 square meters. 0.018 square meters. Clear? Next. Then you have to find out the discharge in the third pipe. You don't know the discharge. How do you get the discharge? As per equation, this is attached to one pipe. So how much of discharge is passing through this pipe 1, that will be diverting in the pipe 2 and pipe 3. So the sum of pipe 2 and pipe 3 is equal to pipe 1. Clear? Q1 plus Q2. Sorry, Q3 equal, so Q1 equal to Q1 plus Q1 equal to Q2 plus Q3. Just a minute. Q1 equal to Q2 plus Q3. From this, you know very well Q1, that is 0.142. Clear? Next, Q2 0.045, 0.045 plus Q3 is nothing but A2 into, sorry, A3 into V3. A3 into V3. Then you will get A3 into V3 is equal to zero point 142 142 minus 0.045. Okay, I brought this Q3 this side. Then you will get 0.097. Okay, so from this you will get the velocity V3. You don't know velocity here. Understood? So you have to find out the velocity at point 3 or in pipe 3. That is V3 equal to this discharge 0.097 divided by 0.018. 0.018. This is A3. Okay, velocity at point 3 equal to discharge by area. Then you will get 5.4 meters per second velocity at point 3 or pipe 3. 5.4 meter per second. Okay, so this is the problem. Now you got discharge in the pipe 1, okay, discharge in pipe 2, discharge in the pipe 3, and velocity also in the pipe 3. Clear? This is the problem. Next, try to solve this problem. Water is flowing through a horizontal tapering pipe AB with a discharge of 0.5 cumex. The diameter at A and B are 30 centimeter and 60 centimeter. If the pressure at A is 7 meters of water, find the pressure at B neglecting the losses. Okay, try to solve this problem.